G'day, Ben from Duck Playing Chicken here with the episode 2 of this build of the Bandai Yamato Mecha Colle Dreadnought class sets 1 and 2 from Space Battleship Yamato 2202. I want to talk about the lighting and what I want to do with the lighting, and the best way to do that is probably actually just show you. Point this up. In a second you will see the first of all the small rear engines light up, and then the next part of the sequence will be the larger engine. And it's a little bit difficult to see on camera, but it will actually pulse, so it's sort of going from a yellow to a yellow-orange. And it will go through this cycle for about a minute, and about halfway through you'll see the wave motion can kick in. Now I've still got to tweak the colours used and the timing of it, but essentially, yeah, I've sort of got a minute sequence that sort of goes through everything where the gun fires and then eventually the engines sort of shut down. Let's see, there we go, there's the large engine, and then the smaller ones will follow. So I've sort of set it up that it'll go on like a minute cycle. So I'm going to take you through the process of how I got to this point and show you on the one that I haven't actually sort of put any of the lights in or anything. So let's make a start on that. Let's start with the LEDs I'm using. These are SK6812s. They're addressable RGB LEDs, and what that means is that you might have a whole string of LEDs all joined up, and you can program each one independently to do something different from the one next to it. So these give you a lot of flexibility as far as the color of the light you want to use and when that light's triggered, doing crossfades, those sort of things. These types of LEDs, these addressable LEDs, they come in lots of different formats. They come in sort of surface mount format. These ones are kind of a little bit different in the fact they actually have legs on them. So they are quite small, but you can see they've got 4 little, if I can hold them, they've got 2 little legs on each side. And for me, this is kind of what makes these really good, because they're a lot easier to solder onto wires. And of course you can buy strip lighting addressable RGB LEDs, but these I find I don't necessarily need, you know, in the case of this this project, I only actually need 4 of them. I don't need a whole strip, and trying to fit a strip in to one of these Mecha Colle kits is not easy. So what I'm going to do is just bend the legs down, and I'm going to talk about which leg does what in a minute. I'm just going to bend these down and show you how I sort of solder these. Just bend them down at sort of 90 degrees, so they sort of, for focus, sit on the side there, like so. And if I hold it up to the camera, you will see that one of the corners, the top there, it has like a little cutout. Okay, and that's a key to identifying which pin does what. So what I've got here is my detailed CAD drawing of what the pins actually do on these LEDs, and sort of a little bit about how they get wired up. So if we have a look at this little cutout in the top right hand side of the LED, the pin directly above that is for the ground, and then on the diagonally opposite corner you've got your positive. So those two deal with the actual power to the LED. The other 2 points are about basically sending a data signal through the chain of LEDs. So you have an in, so this is say from your Arduino board or whatever controller you're using, feeds in, and then you've got the out. So that way you can go to the next LED in the chain, so going from out to in, and that way when I'm doing the programming in the Arduino, I can say, okay, I want this LED to flash red, but I want this one to flash blue. Okay, so it will be able to work out which LED is which in the chain because of this in and out pin setup on each of the LEDs. the next thing is, what am I going to use to program these? I am going to use one of these, which is it's an Arduino board, and it's called a Seed with a triple E, and it's made by a company called Xiao, and this is the SAMD21 model. Now, there are new versions of Arduino boards coming out, what feels like every 5 minutes. These things are great because they are so small. So if I show you one that I've already opened, you can see how big they are. They're quite tiny. So I'm going to be using one of these, and I'll be able to fit it in the base, no worries. It wouldn't fit within the craft itself, but I don't need it to. All I need is for the wires from this to go up through the base and the post into the craft itself. And these things are relatively cheap. I think I paid $7 or $8 Australian for these on AliExpress. They are Arduino compatible, so you can write the code in the Arduino IDE, and they're really quite amazing for the size of them. Now, I used a couple of these. If you watched my 1/1000 scale build of the Battleship Yamato, I used a couple of these. In this one, I'll be using one for each craft, so I'll just have one in each of the bases. The next thing is to try and work out what sort of wire I'm going to use. Now, the actual posts that I've got going into the base, they're only 3mm diameter, and that's the external diameter. So the gap in the middle is quite narrow, and what I'm going to use is just some magnet wire. So this stuff is, what do they say, 0.2 millimeters? Like, it's really narrow stuff, and it's a bit hard to see, but it is copper wire, but it's covered in an enamel coating, and the enamel coating works as an insulator. Now, this stuff's great because it tends to hold its shape really well. It is quite robust, and given that we're using such low current in this particular circuit, it's going to be fine for lighting up just for LEDs. The method that I use for soldering this stuff is because you have to remove the enamel coating first. So I'll take you through how I remove that and about soldering up the LEDs to it. Okay, I've got the wires set up in my Omni Fixer, which is a great device for holding electronics ready for soldering. And grab my soldering iron. I'm going to put a little bit of solder on the end of the tip here, and then I'm actually going to use that to burn off the enamel coating on the wire. So you can see how you've got the silver bit on the end, which means we can solder that, and then the enamel is sort of burnt off. So that's what I'll do in order to prepare the wires, in order to solder them to the LED themselves. Next thing I do is take my addressable LED that I've bent the little legs on, clamp it in on this here, and for this I'm going to use it's just a flux pen. I'm just going to put a little bit of flux on the legs because it just makes it a little bit easier to get some solder on it. These things are pretty hardy, but you don't want to keep an extended amount of heat on the legs, or it will sort of make a mess of your LED. Alright, so to prepare these LEDs, I will get a little bit of solder on each leg. You literally just touch it there with the solder and the soldering iron. The flux will help the solder to flow, and it's just going to make it easier when it comes to soldering the wires on. There we go. Now, I tend to find that with this magnet wire, I'll use green for ground and I'll use red for the live. For the data lines, I'll just use orange, so I'll just use a different sort of colour to nominate that. Okay, now next step is to identify which pin is the ground, and I know it's this one because there's a little cutout on the corner here, so I want to solder that in place. I might switch it around so I'm holding the wire with my left hand. A literally just solder it like that. A nice quick bit of heat with soldering iron, and it's good to go. Now you do need to sort of be a little bit careful that you don't get any areas that sort of short out or anything like that. So you just got to be a bit careful. But that's the ground, and I know the opposite corner, that's going to be my positive, and then I've got my data in there and data out on the other side. So what I need to do now is basically set up my chain that I showed in my illustration to have all the LEDs sort of hooked up. And there's only 4 of them I'm going to use, so it's not a massive chain, but I'll do that off camera and I will show you the result of that. Okay, I've created my chain of LEDs. So at the end here, I've just soldered on some header pins just to make it easier to plug into a breadboard with my Arduino in it. And then if we follow this chain, I've sort of twisted all these wires in a way that's going to make it easier for them to actually go into the model. But basically it goes to this one first, okay, then it sort of tracks around out to the left here, then to this one on the right, and then the one that's the final one in the chain sort of out here. So this is a very simple chain. If you were to take strip LED lighting, it's the equivalent of just taking sort of 4 of the LEDs out of the strip. But at least this way I've got control over how much distance between them. Okay, so that's what it looks like. There's plenty of tutorials on the net of using addressable LEDs. You know, I'm not going to sort of try and go into too much detail, but just I find them a very useful tool for lighting kits. And certainly when it comes to these Mecha Colle kits, previously I've just used straight, you know, white LEDs, and now it's time to sort of step it up a bit. Okay, in order to get the LEDs in place and secured, I'm going to be using some UV curing resin, and it's going to be a bit tricky to show because it's quite tight in here, but basically there's each of these small little engines at the back will each have an LED, and I'm actually going to set it right back here. The reason for that is because I want to attach a fiber optic that's going to go out, and I don't want the fiber optic to butt up directly against the RGB LED. The reason for that is because RGB LEDs, they actually have the 3 different color LEDs within them. So if you get the fiber optic too close, it may only pick up one of the 3 colors. So I tend to find that it works if you have the LED set in the back, and then you bring in a fiber optic and you sort of set it, create like a light pipe with the UV resin so that the fiber optic's not right up against the LED itself. So I need to mount both of these side LEDs within that gap. So I'm going to start with some blue tack to try and hold this in place. I'm going to use another bit of blue tack just to try and hold all this in place, because otherwise it's going to get tricky. You'll let me know if I'm off shot, I assume. Now this is really just to sort of tack it in place. I'm actually going to fill it up with a lot more resin once I get the fibre optic in place. Okay, you can see both of those LEDs in place now. I apologise for the quality of the video. I am zoomed right in and it's not great, I know, but at least you get to sort of see, you know, these are the holes here for these engines, but you see the LEDs are set back quite a fair way. So next step is to get some fibre optic in there and set up this so that the light transfers through the fibre optic. Okay, so what I have here is 1mm diameter fibre optic, and I want to feed it in the hole that I drilled previously, the last episode in the series. I'm going to sort of feed it through there. Hopefully you can see the end of it. It's a fair way away from the LED, but that's actually what I want. So I'm going to fill that cavity with resin. Hopefully that'll capture the fibre optic so that the light transfers through. Okay, hit that with the UV light. Okay, I'm just testing to make sure that the light is transmitting properly through the fibre optic, and yes it is. So you can see it sort of fills, you know, that whole area that I filled up with resin, but that's good, it's acting like a light pipe. So then I can cover this in black paint to light block it all, and we'll get a good flow of light through that fibre optic. Both fibre optics are working fine, plenty of light transferring through. As you can see, I'll need to do quite a bit of light blocking in there, so that's alright, nothing a bit of black fabric paint won't fix. Now for the large rear engine, I need to get this LED sort of in here and located back from the diffuser a little bit. So a bit hard to sort of see there, but trying to get it and also trying to get a little bit centered. Okay, the rear engine LED's in place, and so diffuser seems to be working really well. The further back you can get the LED from the diffuser, the better the result will be. You'll get less of a hot spot. Now of course it's blowing out a little bit on camera, but in real life, yeah, you can't actually see the LED hotspot at all, so it's a really nice little light. So that's the rear 3 lights done. The next one is the wave motion cannon. Okay, for the wave motion cannon, if you watch the last episode, I created this little light box tube, so it's just a bit of clear, frosted clear styrene over the end of the tube. And what I want to do is attach the LED to the open end of it. So I'm just using my clamps here to hold it in place. So I can sort of get it lined up. And then again, I'll just use some UV resin just to sort of hold it in place. I need to slide this tube into the end here. Sort of slide it as far as it'll go. So there we are. Okay, just testing this, waiting for the wave motion cannon to kick in. There we go. Looks pretty good. So that works pretty well. I haven't actually fixed this in place, so I'll be using some fabric paint to light block it, and I think that'll be enough to hold it in place. It doesn't really matter if it comes loose, it's not going to sort of fall all the way out, so yeah, I'll probably end up going down that path of just using fabric paint to lock it in place. Next step is to do some light blocking, and for that I'm just going to use some tulip black fabric paint. I tend to get this stuff all over myself, but it works really good for light blocking. It's got this great little nozzle on it. So I'm going to sort of get in all the gaps and around the back of the LEDs. Okay, once I've got the first sort of bit done, I'll actually plug it in because I find it a lot easier to work out where the light's still leaking when it's all turned on. So let me do that. I'm sure there's probably lots of holes that we'll be able to see. Yeah, so all around these gaps here. whole areas I missed underneath. Just waiting for the wave motion gun to kick in so I can check that one for light leaks. Oh yeah, what's underneath there? Okay, I might leave it at that. And what I'll do is I'll let this dry and then I can go back and test it again. This stuff tends to take a while to dry, and I've made a mess all over the place of this stuff already. It doesn't take me long, I don't know what it is, but I tend to get all over my fingers or all over the model where it's not supposed to go. It's messy stuff, but it works really well. Alright, so I'm going to let that dry, but as far as the actual sort of lighting goes, that's pretty much it. I will go back and check for light leaks after the first bit of fabric paint's dried. I won't show that on camera. And then we'll start looking at sort of the next bit in the lighting process. All the fabric paint has had a chance to dry, so now I need to trim these fibre optics. And in a lot of cases you kind of think, why would you trim them before you do the painting? And the reason being is these little nozzles that go in here, they just won't sort of go over the fibre optic and sit in there nicely. So I've actually got to trim these back, and I'll end up sort of masking it. So I'm just going to try and cut these down as close to the edge as possible. Just the nature of the little nozzles that go in here has to be pretty flush. So I've got to go in there with a knife. I just trim those fibre optics so that they're reasonably flush to the surface. Now I've got to try and get the nozzles in and see how they fit. Okay, get the nozzles in place. All seems to be working pretty well. Pretty happy with that. And what I'll do is I'll just put a little bit of blue tack over the where the fibre optics protrude. And when I do the painting, I can, after I've done the painting, I can just remove that blue tack, and it should be all good to go. I'm going to talk about the code that I'm using, the Arduino. There are plenty of tutorials out there that go into better detail about how to do this stuff. And the other thing that I should let you in on, a bit of a secret, is that I actually used an AI tool to generate this. So whether you use ChatGPT or DeepSeek or something like that, these tools are actually really good for writing basic Arduino code. And certainly when we're talking about something like sequence lighting and all those sort of typical projects we might have in model making, they can actually do a really good job of putting some code together for you. So I did cheat on this code. This is not entirely my own. The principle of this code works on the idea of what's called a state machine. So a state machine allows you to check what state something is in at any given time. Now this is really important for like Arduinos, because a lot of the older sort of Arduino boards, they don't do multitasking, so they can only do one thing at a time. And that's a real problem if you're working with addressable LEDs and you want, some one LED to fade in and out while another one is fading in and out at a different rate. Now, normally if you're just starting out with Arduino code, you might use the term delay. And delay basically pauses what's going on. So the problem with that is when you use a delay, everything stops. So you can't have sort of other LEDs, fading in and out and that sort of thing. So state machine is the way to get around that. So the way this code works is, first of all, I'm using the fast LED library for this. And that actually sort of sets the colours and the fades and transitions the colours of the addressable LEDs. I've got a couple of variables starting at the top, the number of LEDs. So of course I've just got 4. I've got 2 for the small engines, 1 for the large, and 1 for the wave motion gun. The data pin, so for my little seed Wino, it's just going to be out of pin 8. And then I've got some variables for the which
number the LED is in the chain. And when we're working with addressable LEDs, it actually starts with 0. So the first one in the chain sort of has an index of 0, not an index of 1. Next, I have a number of variables that are around the timing and the number of cycles. I wanted to make sure that it was easy for me to manipulate the timing of things without having to go in and change sort of a whole lot of code in other places. So that's why I've used a lot of variables here. If I use the example of the small engine, so I've got small engine wait time. That's how long it takes for the sequence to start from the very beginning. So in this case, it waits 10 seconds before something happens. You see a number here, 10,000. That's because it's always measured in milliseconds. 10,000 milliseconds is 10 seconds. We've got the small engine fade time. So this is the time between pulsing from one color to another. So in the case of the small engines, they go from yellow to orange red and then back to yellow. So it takes 2 seconds for that transition to occur. Then I've got a fade to black time. So this is when the small engines first start up, they start at black and then they transition to yellow. And I wanted that to be a bit longer. I wanted the engines sort of to warm up over a little bit more time. And also when the engines turn off, they will fade out for 5 seconds. And then I've got the cycle count. So how many times do I want the transition from yellow to orange red to, how many times I want it to go through that sequence. I've got a couple of variables for the colors. And then basically for the other LEDs, so for the large engine and also for the wave motion gun, I've got the same types of variables. The process I'm using here is exactly the same for the 3 components of the lighting. Okay, then we get to sort of the state machine part of it. So this is where, we're basically, think of it as a timeline from the start to the end. And as we progress through that timeline, we want to check the state of any given LED. So whether it's turned on, whether it's transitioning from one color to another, or whether it's fading to black. And so that's why we have these sort of state machine variables here. Small engines waiting means not doing anything. Fade from black, at the start of the sequence when it goes from black to yellow. And then we want it to fade to the second color, back to the first color, and then fade out to black. And then we also have a variable there for complete. And so this is basically our flags, if you like, to tell us what state any given LED is supposed to be at any given time. And of course the same process again for the large engine and for the wave motion gun. Wave motion gun has an extra variable in there just because it has an extra color in the sequence, but the principle is exactly the same. Now when we set up, we have to obviously initialize our fast load library, so we have to tell it how many LEDs, that sort of thing. We have also got to say what the start time is for the small engine, the large engine, and the wave motion gun. So here we are checking, or we're setting a start time for each of these components, and we use the term millis, which just takes the current time. Everything sort of happens within the loop. So, it basically goes through the whole sequence and then it starts again. So there's a whole lot of sort of stuff that's going on in this loop sequence. The first bit is we are checking the state of the small engine, large engine, and the wave motion gun, and we check that against the current time. We want to update the LEDs, so we basically send a command to each of the LEDs. It might be changing color or whatever, but we want to show those LEDs. We want to show that update, so the LEDs won't turn on or do what you want to without that command. I've got a helper function in here. This is just for troubleshooting. The next function we have here is the actual state machine mechanics. So this is where it's checking what the current state is and whether it needs to change. Now, there's a lot going on here because we're basically checking the start time versus the current time, and we're checking what the current state is for any of the given LEDs. So I don't want to go through it in too much detail, and I should say I will include a link to the code, so if any of you want to use this code, you're more than welcome to. I'll put a link in the description. Okay, and that is essentially repeated for each of the components. So small engine, large engine, and the wave motion gun. Here we have the wave motion gun, which has an extra color in there. So there's a couple of extra lines. And then finally, we have the function for fading from one color to another. And the variables I showed at the start where we set the colors, it just makes it a lot easier to do it that way. So I don't need to sort of calculate the RGB values, for each sort of fade sequence. This helper function does it for me. So all I need to do is define what two colors I want, and this helper function will determine the best way to go about that. So that's the code. Like I said, I'll leave a link in the description. And just a note on that, please don't ask me to help you write Arduino code for your particular project. I'm not an expert in this field. There are lots of tutorials on the net. I've got just enough knowledge to be dangerous. So please don't ask me about Arduino coding issues you might have with your particular project. But, you're more than welcome to use this code and manipulate it as you see fit.
The next step is to get some of these pieces glued in place. So this one here, I've taken pretty much all the tabs off, so there's really nothing holding it in place at the moment, and there is just a little gap. It's a bit, you can't see on camera, but I can see daylight through this gap here, so I want to close that up and with a bit of glue. I'm going to put this top piece on, just so that I've got something I can clamp it to. I'll take some Tamiya extra thin. Yeah, should be able to clamp it. It should set up just fine. Make sure there's sort of no gap there. And it will be just a matter of sort of working through the different pieces. The top part, I want to paint the deck first and then mask that off and then glue it in place. And then of course we've got this bottom piece which the wires go through, which will probably be the last one I sort of glue into place. Okay, the next piece I'm going to glue in is this piece that goes underneath with the tube that I've epoxied in, and I've also painted it black and masked it off, ready to go. Now before I attach this, I've taken all the tabs off, just cut them all flush because I won't need them because I'm gluing it in place. And the other thing I might do is actually get this middle fin glued in place as well. I don't know, actually I don't even know if it needs glue. It probably doesn't. It's probably fine if I just I won't be putting in these little things on the side because they actually need a bit of masking, so I'll leave them out for now. So I think I might just leave that in place. I'm going to feed these wires down through the post. Just want to make sure it sort of sits in place, which it does. So now I'll just grab some Tamiya extra thin and glue that in place. There's also a little piece in here that I can glue in. I mean, I've got this post that I'll be able to hold it when I'm doing the painting, so anything that hangs below that is not so much of an issue. So it's spot glue. I have to get a peg in there to hold that down, I think. Okay, so this little fin piece, I think I need to cut this tab off. Again, when you're gluing all the pieces in, you really don't need very much to work out where the piece actually needs to sit. And it's actually holding in place pretty well, but I think I'll still get some glue on it. Okay, now I've got this little box here of all these other bits and pieces. So it's the front nose piece that'll be painted separately. This intake will be painted separately, different colour. The end cap, of course, that'll be painted a separate colour. Now for the bridge, I don't really want to glue that in place just yet. So for the top deck, I want to paint that first, mask it off, and then I can glue that in place, and then I'll look at the bridge. So that's staying off for now. This front nose piece will remain separate. It's the same grey colour, but it'll be separate. It goes over the front of the nose. These two drop tanks, or whatever they are, they actually need some masking, so there's like a band that goes around them. So I'm going to leave those separate. Also the guns. The guns, I'll paint them separately. Now there's some bands that I've got to try and paint on them, and I'm tossing up whether to go. I think I'll probably end up just hand painting them on. They're very fine sort of little bands, so I'll leave them off the ship for now. And then there's the little side nozzles, which have to be painted a separate colour, so I'll keep them separate as well. Okay, I've got all the craft up to the same stage. Bottom plates are all glued in, ready to go with the stands. So now it's ready for painting, masking, decals, which I will leave until the next video. So till then, I'll catch you later.